Okay, in these problems, we're trying to connect the Riemann sum, this limit sigma definition that you see here, with the definite integral. So we're trying to figure out how can I rewrite it to be this. Okay, the first thing that I always check is the dx piece. Remember, the dx is the width of the rectangle, and you're multiplying it by every single time. So in this case, this has to be dx. It's got to be 3 over n. So then when you look at these integrals, remember, this is the interval you're looking at, and you're dividing up over n number of rectangles, so your dx has to be the width divided by n. So this is 3 over n, so that seems to work. This is also 3 over n. This is also 3 over n. This is also 3 over n. So that piece doesn't help us narrow down our answer choices, but that's what I always check first, because sometimes that might help you to narrow down your choices. Now, the next thing I look at, okay, what is my x? And sometimes it may be a little bit trial and error. So I'm going to say, okay, it looks like maybe I have two problems where x could be all of this piece. So let's say that x sub k, so that's your general x, is this, 3k over 1. 3k over n plus 2. So f of x sub k is really x squared. We are taking this entire function and squaring it. And then we want to make sure, if I pick this as my x, do the bounds make sense? So remember, your lower bound is where do you start? So we're taking an infinite number of rectangles. So what you want to do is plug in 1 for k, because that's going to be your first rectangle, into your x sub k, and what's this limit going to be? 3 divided by infinity, remember, is 0, because that gets smaller and smaller. So this limit is 2. So this is my lower bound. And then I want to know, where's my last rectangle? So we're going to plug in n for this k right here. And this limit is going to take me to 5. So this is how you determine what the bounds are on that integral. So using my setup, it looks like this would be the definite integral that matches this Riemann sum. Okay, let's try the next one. Okay, again, I start the same way. This time, I'm given the definite integral, and I have to match it to the Riemann sum. So I'm going to start with the dx like we did before. So from here, I can tell you that dx is going to be 5 minus 1. That's your interval. You're dividing it up over n rectangles. So my dx has to be 4 over n. So usually I can tell pretty easily what the dx is, because that's going to get multiplied through every single time. That's the width of your rectangle, and this will be your f of x, whatever this function is. So I can tell right away it can't be b or d, right? The only one that has the 4 over n is got to be your A or C. So we're at least down to these two, okay? So I'm going to pick one to check, and let's see if this works. So this one, your x sub k is 1 plus 4k over n. Okay, so that your f of x sub k would be x cubed, which is what I have here. The only thing we have to check is, do our bounds make sense? So we need to check our beginning bound. So you're going to plug in 1 for k. It's where we start. This limit is 1. And then our very last rectangle, or the ending bound, would be 1 plus 4n over n. And this is 5. So the bound goes from 1 to 5, which I can see that's what this does. So it looks like C makes sense as your answer. Now, if you started with A and checked A, let's see why that doesn't work, okay? So if you try to use A, so there's my dx, your x sub k would be 1 plus k over n, right? You're still taking that function and cubing it, so that makes sense. But let's see if our bounds make sense. So my first bound would be 1 plus 1 over n. That limit is 1. That's fine. Your upper bound would be 1 plus n over n, which only gives me 2, but my definite integral needs to go to 5. So that's why A cannot be the answer. Okay. So let's try number 3. So again, I notice that dx in this case is pi over n. So it can't be A or C. So I'm left with these two. So I would just say start with one to check. Let's check C first. So your x sub k, notice the function is sine of So this has to be your x sub k somehow. So notice in this problem, the sign is already there, the 3 is already here, so your x would just have to be the k over n piece. So that would give you f of x sub k equals sine of 3x, but let's check our limits. My first bound would be 1 over n is 0, and then your upper bound would be n over n, if I plug in n for k, which is 1. But if I look at my definite integral, it's not going from 0 to 1, it's going from 0 to pi. So this is not the answer, but we can check D just to make sure. So in this case, your x sub k, because the sign and the 3 are already there, would this be this? Pi k over n. So f of x sub k is still sine of 3, and then this is my x. So let's check our bounds. So I've got pi over n is 0. And then my upper bound is pi n over n, which is pi, and those are my bounds. Okay, the next one, notice that they have actually written it out with the limit statement, and they're adding up all these things from 1 all the way up to n. So they're just, instead of writing the sigma, they've written out the expanded notation. So hopefully we notice that your dx is going to be 1 over n, because that's what's getting multiplied through by every height. So let's see, does that help us narrow down any of my choices? No, it actually doesn't. So at this point, you're going to have to kind of try to see if you can tell which one it has to be. I'll just tell you which one it is, and we can check that one. If you check the other ones, you'll notice it doesn't work. So if I'm going to do this, I'm taking the square root of everything inside. So notice the inside is what's changing. So notice, oops. What's happening is, so this is my x sub k. So the number on the top that's changing, that's my counter, that's my k. So x sub k in this problem would be k over n. So what you're doing to that x value is taking the square root of it. So that would match up with what I have here. And let's check if our limits make sense. So 1 over n is 0. Upper bound would have to be n over n, which is 1. And yes, it does. So that's why B is my answer. Okay. Next one, dx has to be 5 minus 3 over n, which is 2 over n. So that rules out these two. So let's try to, we got to figure out which one of these it has to be. I'm going to check this one. So x sub k would be this whole thing raised to the 4th. So it has to be all of this. And then f of x sub k is x to the 4th. So let's check our bounds. 3 plus 2 over n will give me 3. And then 3 plus 2n over n gives me 5, and that's what this definite integral is. So the answer is D. Okay. And the last one. So I'll notice this is my dx. So notice that's going to rule out this one, because dx here would just be 3 over n. This is also 3 over n. Be careful here. You have a dx of 3 minus 0 over n, but then when you multiply by the 1/3, this still gives you 1 over n as your dx, so D could still be the possibility. So we would have to check that one to see which one works. I'll check both of them for you. So if you think this is your function, you are thinking that x sub k is k over n, because you already have the 1 here. You already have the plus 3. So the only thing that's changing, that's your x, is this k over n. So that just goes in here. Okay, and let's see. So f of x sub k is square root of 1 plus 3 is already there. This is the only thing that's changing. There's my x. So if I take the limit of 1 over n, that's 0. N over n is 1, and yep, that matches up. If you tried this one over here, because you're taking the square root of everything inside, you would have to pick your x sub k as 1 plus 3k over n. And your f of x sub k would be square rooting that. Okay, but we got to check our bounds. So let's see. 1 plus 3 over n is 1. And then your upper bound is 1 plus 3n over n, which is 4. And that does not match up with this at all.